Hello, hi, uh, good evening everyone. This is Priyanka. I'm working as assistant professor in the Department of CSC AIML. And coming to this FIP conclave, this is the overview presentation I'm going to present right now. And everything is related to whatever we have experienced during the FIP summer presentation, which was conducted in 2025 May, and it was completely for 1 week. And I personally feel that this is really helpful to making my skills more and more flexible to the student and Gen Z students like that. So, and coming to me, this is Priyanka, and I have over 11 years of experience in teaching, and I'm handling various labs. I have experience of guiding projects, going for administration works and event management. And frankly speaking, in this 11 years of experience, that was really a good journey of mine where I enjoyed each and every day of my teaching, each and every class of teaching. And I'm a kind of teacher, like where I can say I can stand myself, I give importance to the students, and I first think myself as a student before I teach some topic to them, like whether they will understand that or not. If a student of first year or second year, according to their level, they wanted to teach or they wanted to grasp any concept, I will teach accordingly, like giving more number of examples and everything. And this FIP helped me to nurture my skills more and more, where I can implement more kind of strategies for effective teaching strategies and everything. And this is about my self introduction. And coming to FIP, in the module 1 we were taught with brain based learning. What do you mean by brain based learning? So brain based learning is something where some expertise have been doing some research regarding how a human is going to analyze some topic, and how a human will be able to grasp some topic, or how a human brain is going to absorb some kind of knowledge from the environment and everything. So according to this research, as mentioned here in my slide, mind mapping, movement breaks, hands-on learning, and chunking information, these are the 4 modules majorly I find that it will be relevant to my teaching methodology, because I personally belong to a computer science guy, and I am trying to teach next generation computer science engineers. So this is most important for me, where I have to train myself, like before giving a lecture I am supposed to give train myself, like how to present myself, how to present a particular topic regarding programming or anything. So coming to this, I was asked to discuss about any one of the thing, and the most kind of thing I like in this brain based learning journey is incorporating mind mapping and hands-on learning in Python programming. So presently I'm going for Python programming for first year, so that is the reason I wanted to take this example and move on. And here what I have, the example I've taken is, so here, for example, if I wanted to teach polymorphism for my students, first year students, so they don't know preliminary kind of things like what is polymorphism, what the basic kind of things, and how they can implement in real time applications and everything. So what can I do is nothing but I'm going to seek one small examples. So I'm going to explain what is the meaning of poly, what is the meaning of morphism. Poly means many, and morphisms means forms. So something is going to exist in many forms based on their existence, like where they are being called. So here what I'm trying to rake is nothing but, so in this way I'm trying to explain. So I'm trying to map the student's brain to the topic, like, so here I've defined one class called cards. In that, drive is my class, where I'm going to call it in different classes. So for example, cards is a parent class here. In this, if I call the same drive cards in automated cards class, the thing is like whatever the implementation, whatever the logic I'm going to give in the automated cards is going to be different, and when it is a manual card, the driving methodology is going to be different. So this is how a student can map his mind towards the concept, and he can implement the kind of I can say that he can create an ambience like, okay, this is what I'm going to do, like that, and he can involve in the topic and he can carry on. So this is what I tried and I've already implemented in this. And coming to this Bloom's taxonomy, there is a kind of hierarchy where different kinds of levels like understanding and understanding level, apply level, evaluate level, analyze level, different kinds of levels are there. So whatever an engineering graduate is supposed to be taught with is, he is supposed to get some analyze and evaluate levels, so that he can I can frankly say that he should be in a position like he has to apply something. So that's where I have learned the importance of what a Bloom's taxonomy is going to be, and framing as I have analyzed. So I thought that this particular hierarchy, whatever the pyramid we are going to have, that is to be mapped to my class concepts, so that wherever I'm trying to pose some questions in the mid exams or whatever the exams I'm trying to conduct, so that should be a scenario based question. So this is what I've learned in this FIP, and I'm really grateful to say that whoever the tutors like Radhika ma'am and everyone whoever taught us, they have clearly shown the importance of this, and I have really enjoyed this. So coming to this, in the scenario based questions, whatever I've considered, so this is a basic level question, and analyze the disadvantages and advantages of single and multiple inheritance. So whatever the things I'm trying to present here is related to this Python programming, as I'm going with that, right? So here, a scenario based question, like I'm going to consider some e-commerce platform where it is going to a particular company is trying to implement some inventory management system, so that when he wanted to implement this inheritance to that, as I already taught them with some real-time examples, it will be easy for him, and he can imagine he can create some ambiences like okay, this is going to be a parent class, from this parent class billing is going to be a subclass and everything, and he can implement it easily. So this is what framing high level questions is going to look like, because they are completely related to this high level questions and scenario based, so that it will help students to go with real-time implications and everything. And this is other examples. And so according to my analysis and according to my kind of I can say that methodologies I have included in my teaching, this are going to enhance the critical thinking. Like a guy or a student from medium to higher level, he is going to map his brain to the real-time scenarios where he will be able to implement in the when he gets placed in the industry. So he is going to recollect the concepts easily, and he can use his skills of programming being taught in my classroom in the real-time industry experiences. So this is what, and I already had some feedback from the previous college where I've worked for this, and so this is really working like a pro. Right? And coming to CO mapping. So this is of course important. Before we are trying to teach from codes, we are supposed to create some CO mapping, right? So here CO mappings are, we are going to design some course outcomes. Along with this, we are going to give some program outcomes. So this is going to be a kind of thing like where what is the expectation of our program outcome for BTech, and what is my course is going to map for this. This is very important, and I really learned so much in this. And coming to the design of rubrics, what you mean by rubrics? Rubrics is somewhere we are going to create a criteria. How can I evaluate the student's performance? So if I'm trying to conduct a seminar or a presentation, I am supposed to take some rubrics, some points like his body language, how he is trying to present, what are his communication skills and everything, so that I can help him easily. And coming to this real-time applications, so here the same thing, whatever the things I have been doing, that I'm going to do it in a kind of hierarchy from one module to other module. I've been enhancing my teaching skills like anything. I'm trying to gather more and more kind of real-time applications where it is going to create an impact on my students' engagement and class management. And coming to this LMS is something where platform, it is really helpful for me for uploading some videos, uploading some kind of materials, conducting some quizzes and everything. I'm using using it. I've been it's been 3 months I've been joined in this college, and I've been using this for collection of quizzes to evaluate their performance to time and everything. And coming to this ALS activity, so here my ALS activity was like I was like I have created one ALS activity somewhat different, like code annotation and explanation. So here what I've did is nothing but I've given some set of code to them, and some set of set one code set to something related to some of these concepts. And for that what I did is nothing but I have ask them to select one kind of a question from every team, and they are supposed to annotate that code. Like if for example if condition is there, how it is going to work, like, and what are they are supposed to annotate them. Annotation is nothing but they are supposed to explain them in annotations for the code. So this helped the students very much, and this is the schedule I followed there. And the response from the student side was also really like a very good, like they have enjoyed it. And there are some sample pictures and video. I'm trying to play it, but time is running out. So module 8, active learning strategy. So here in this active learning strategy, this is the feedback I've collected for myself. And closing remarks: complete FIP. I've analyzed that integrating active learning strategies and everything, every module into academics is very important for a student's development, not only for students' development, for also my personal development, so that I can stand different, or I can stand unique in a group of teachers if I am working like a pro with this. Thank you so much. Thank you, Team IQAC, for giving these skills for me, and signing off. Thank you.